Yo, it's Professor McStud, and I'm coming at you with functions today. A function is a relation where basically a relation is any x and y put together, where there is only or exactly one output for every single input. So we're going to look at see what these look like. If it's a function or not a function. That's all we are determining today is functions or non-functions. So here it wants you to note on the example, it gives you a list of ordered pairs, and this right here is called a mapping. That's what this is called. So if you ever see that, that's what that's called. So a mapping. So all they did is they took all the x's and put them in what's called the domain here, and then all the y's go into the range. So that's the y, this is the x. So note here, this point right here, -1, 2. So -1 is the x value, and that's from the domain. It goes to the range of 2 of y. I won't always list these as domain and range. I'd probably list these as x and y, but that's just kind of sort of just a little bit more vocabulary for you to get. When you have a mapping here, your domain cannot split. If it splits, it's not a function. So, but it can merge. So 0 can go to 2 here. So what you're looking for basically is that x does not repeat. X cannot repeat. Meaning that every single x has a certain y. So if x3, let's say x is 3, it cannot go to 4 and -7. So that's what that means. X cannot repeat. So we'll look at that real quick. So look at this example here. We have a domain, which is our x values, and our y value as range. So before it went and wrote your ordered pairs as a mapping, I would go through here and write these at ordered pairs. I think you guys can see this a little bit better, maybe even more so as a table. So that's what I'm going to do here is write this as a table. So here's my table here. All I did is I took this mapping and I wrote it here in this table. So -2 went to 5, -1 went to 2, 0 went to 1, 1 went to 2. So in that we have, you can see your x values a little bit better here. So note that none of those repeat. So this is a function. So this one is yes. So a question that you might ask yourself is that, not does every single x repeat, because then you say, no, it doesn't repeat, no, it's not a function. You kind of tie those together. But is every single x different? Yes, every single x is different. Yes, it's a function. So you kind of, maybe that's maybe how you have to train your mind. So let's look at this one here. Let's look at all you're going to look at. And when you have ordered pairs, you're looking at the x value only. So 3, 4, 5, and 6. I didn't repeat any single numbers. You don't even look at the y's. Don't look at the y's. Don't pay attention to that. Only the x values, which is the first coordinate in an ordered pair. So this one would be a function. Yes, all the x's are different. 4, 5, 3, 4, 5, and 6. All right. So that's all we're asking. So yes or no. That's your answer. So let's look here. So now you can see here, I'm not looking at the y column at all. I'm only looking at this. Are all the x's different? No. Why? I have a 1 here and a 1 here. So therefore, it is not a function. So this is not a function. All right. So only thing that you're looking for is x value. So your main focus here is going to be at looking at the x value. The x value cannot repeat. The x value cannot repeat for it to be a function. All right. So that's strictly all we're looking for is it a function or not? And if it's not a function, you need to explain why. So here's what I would explain here, is that 1 goes to -11, and then 1 goes to -12. That can't happen. Sometimes it may ask you, what could you take out? What would you change? You could change either this point or you could change this point, either way. So that's something else you can kind of look at, another way to kind of sort of word a question here. All right? So that's all we're looking for. Is it a function or not a function? If it's not a function, you need to explain why. All right, that's it I have for you with functions.